Today we're doing a deep dive into a piece of hardware with, let's say, a very specific name. The NTI ST-C5V2ARS-R-1000SP high-res VGA receiver.
Right. It's a mouthful.
It really is. But forget the name for a second. This device is this incredible tech paradox. You're taking old-school, high-frequency analog signals,
Yeah.
like VGA, and you're pushing them a kilometer away.
And you're doing it over cheap network cables that were designed for digital data packets.
Exactly.
That's really the mission for this deep dive. We're not just going to read off a spec sheet. We want to get into the genuine mastery of signal processing that's going on here. To maintain a perfect signal over these huge distances with the standard KTX cabling is surprising.
Okay, so let's unpack that. At its heart, this is a KVM extender.
Keyboard, video, mouse.
Right. And it's built for legacy stuff. We're talking PS2 for your keyboard and mouse, and that classic 15-pin HDVGA connector for video. For a lot of industries, that hardware is still absolutely critical.
And what's just fascinating is the reach. I mean, this is certified to extend everything KVM, even two-way audio, up to 1,000 feet.
1,000 feet. That's 305 meters.
Yeah, think about that. A normal RJ45 cable, the same one you might have for your internet, is now carrying flawless high-res video over the length of, 3 football fields?
It's wild.
And if you look at the build, you can tell it's not meant for an office. It's rugged steel, durable powder coat finish. It screams harsh industrial environment.
Okay, and this is where it gets really technical for me. The video resolution it supports. It's actually stunning. 2048 by 1536 at 60 hertz.
Which is a very high-frequency analog signal.
So running that far over copper, especially unshielded copper, I mean, shouldn't that signal just fall apart almost instantly? How do they get around the physics of the wire itself?
Yeah, that requires some serious heavy lifting and signal compensation. The device has to automatically clean up and balance that signal. The real problem is something called color skew. Right. Because red, green, and blue are on separate copper pairs in the cable, they actually travel at slightly different speeds over that long a distance.
So the colors arrive out of sync.
Exactly. And you get this blurry, rainbow-edged mess of a picture.
So the device has to be like a micro-precision traffic cop for light speed.
That's a perfect way to put it. It has to perfectly realign those colors. And they let you do fine adjustments with buttons on the remote unit.
How fine are we talking?
You get a maximum delay compensation of 62 nanoseconds.
62 billionths of a second.
Adjustable in 2 nanosecond steps. That's the level of calibration you need for a crystal clear image. And, you mentioned signal degradation. You can hit that top resolution, 2048 by 1436, up to 600 feet on standard unshielded cable.
Okay.
But if you use shielded cable, STP, to protect from interference, the max distance for that resolution actually drops to 400 feet. So even the insulation has its own trade-offs.
That attention to timing is just it's the real engineering marvel here. All right, so shifting gears a bit. Connectivity. Beyond the PS2 and VGA, it also has an optional RS232 control interface. And even though it uses what some people would call outdated I/O, this thing supports a huge range of platforms. Modern Windows, server, Linux, even NACOS. That kind of backward compatibility must be invaluable in some places.
And if you connect that to the bigger picture, the specs hint at highly regulated environments. Each unit only uses 10 watts.
Which is pretty efficient.
It is, but look at the compliance. It's CE and RoHS compliant, sure, but the key one is TAA compliant.
Trade Agreements Act.
Which means it's qualified for U.S. government purchasing, and that ties right back to why it's built like a tank. Reliability matters more than anything.
So when you boil it all down, the NTI receiver, its real feat isn't just extending a signal. It's like conquering the physics of sending an analog signal that far using affordable digital-era cables. It's a really remarkable piece of work.
Which leads to a really interesting question for you to think about. Considering these intense requirements for reliability, for security, for high-res VGA over 1,000 feet, what kind of highly specialized, maybe even classified industrial or military systems would rely on this exact mix of old-school tech and modern cabling? Where does this device sit that reliability literally trumps everything else? Something to chew on until our next deep dive.